C-17 Globemaster III, newly crowned champion of the heavyweight division.
The C-17 is the airlifter to carry us into the future and to get the job done.
The Sky Giant, next. The C-17, the new U.S. military transport, an aerial moving van, the most expensive production aircraft ever built. It has been acclaimed as the most versatile airlifter in aviation history. In Bosnia, under wartime conditions, it lifts 60-ton tanks into the short, beat-up runway at Tuzla. All of the oversized, overweight equipment required by the U.S. Army rolls in and out of its cargo hold. One of the first pilots to make the transition to the new heavy airlifter, Captain Gene Carter.
I've been all over the world. That's one thing I loved about flying the heavies and going into different situations, humanitarian relief, the Bosnia, Rwanda, the hurricane, things like that. Hurricane Marilyn came through the Caribbean and really devastated the whole country. I remember St. Thomas was probably the most rewarding in that the whole island was just devastated. And we went in right after the hurricane, we went in, we're one of the first planes in there, and see the people begging for you to take them off the island, and I couldn't say no, so I'd put them on as many as I could on the plane and get them out of there so they could get back to some sort of civilization.
Food and medicine inbound, a full load of desperate tourists on the trip out. The Globemaster is an aircraft of strategic importance. When the U.S. decides to act as global policeman, it will be the first, and for years to come, the only policeman on the scene. From the sunny Caribbean to sub-zero North Dakota, Gene Carter, on a routine training mission, is diverted to the airbase at Grand Forks, where a blizzard has knocked out electrical power. 2 emergency generators are shoved out of the C-17, and 20 minutes later, Carter is ready to head home.
They moved all the families into the gym, so they're on in the gymnasium, staying warm tonight and sleeping there. So hopefully these generators will be able to repower the houses and the folks can get back home.
In a few hours, Carter and the C-17 face a demanding test of this sophisticated new airlifter and its crews. South Carolina's Charleston Air Force Base has long been home to airlifters. Gene Carter is a dedicated airlifter pilot. Until the arrival of the C-17, he flew C-130 Hercules, and he loves flying the heavies.
Well, I can tell you that on the days that I'm flying, it doesn't matter if it's 1 o'clock in the morning or 3 o'clock in the morning or 12 noon. I get up excited as I could be because I'm going to go fly. That's all I've ever wanted to do since I was a little kid. So every day I go fly, it's like every day's a Friday for me.
Carter's C-17 can fly halfway around the world and land on a short battlefront airstrip carrying the biggest equipment in the U.S. military inventory. Until the C-17 entered service, every airlifter has been too big or too small. Too big to use thousands of the world's airstrips. Too small to carry big tanks and trucks. The C-17 shines on the ground as well as in the air. It can turn on a dime, It can do a 180 on a 90-foot wide runway. It is so maneuverable, 9 C-17s can park in a ramp that can only handle 2 C-5 Galaxies. This ability to squeeze into small spaces means a lot more cargo will be moving when there's a war emergency, and ramp space is at a premium. Carter and other pilots are still testing the limits of the C-17. Today, for the first time, the 437th Airlift Wing will mount a precision airdrop with a formation of 9 Globemasters. It's the first time 9 of these giants of the sky have been launched on the same mission. Hundreds of base personnel prepare for the flight.
It's awesome. I'm gonna work on a little.
Flight planning begins at the Mission Support Center on computers, for the C-17 runs on banks of them.
I can pull up my route on the computer, my air refueling route on the computer, airfield diagrams, airfield information, and I can save all this to a disk. Whereas beforehand, I would have to come in, pull out a chart, sit down, and draw everything out by hand, and I just come in and it's available to me, and I just call it up and download it, save it to my disk, and walk right to the jet with it.
The C-141 Starlifter, 30 years in service, eventually all to be replaced by the C-17. They're about the same size, but the C-17 carries almost twice the load. Today, the old C-141s will provide competition for the new airlifter.
Today, we have a 9-ship C-17 formation and a 9-ship 141 formation. And it's pretty much going to be for bragging rights on the base as to who's the best airdropper around here. The 141, where they have a navigator and basically a stopwatch whiz wheel to make the drop, versus the C-17 with all of its automation and the mission computer that does the actual dropping. Who's actually better, the computer or the guy himself? I got my money on this airplane right here.
In war emergencies, the C-17 will drop tanks or big containers of supplies. On this training exercise, pallet loads of railway ties.
Call sign all day will be Moose 10 for the flight. Our individual call sign is 15. We are the ski master. If you hear anybody calling us in the formation, please pimp us and let us know so we can respond.
Normally, a C-17 needs a crew of only 3. There are extra pilots aboard today, training to fly the aircraft still emerging from McDonnell Douglas's production line. A final discussion of emergency procedures. Lieutenant Jennifer Rainey is the C-17's loadmaster.
First malfunction we probably will have is a loose platform. Okay, that'll come probably at the slowdown checklist. I'll state malfunction. At that time, I'll go into my heavy equipment malfunction checklist.
Charleston ground, taxi to runway 33, wind 270 at 5, altimeter.
We have 3 mission computers on board the aircraft. We have 1 primary and 2 backup. Now look at these mission computers as much like the brain. It's what makes it work. And our mission computer holds all of our information that avionics, navigation, engine monitoring systems, fuel monitoring systems. It's also connected up to the automatic flight control system, which is our autopilot. And so that way we put the navigation information in it and engage the autopilot. Then the autopilot's flying off the mission computer information.
With all of the computers aboard, the electronic voice of bitching Betty is heard frequently in the cockpit.
Sinking. Too low gear.
People call her Bitchin' Betty, but she's also your best friend. When things get hectic and you're in a hurry and you forget something, she'll let you know.
Stabilizer motion.
A line of C-17s on the taxi strip is an awesome sight. Billions of dollars on the move. And when they are joined aloft today by 9 C-141s, 18 enormous aircraft will share a small patch of sky.
During the flight, we're constantly monitoring our time control, monitoring that we are on course, where we're going. When you've got a large formation like that, any type of speed change can trickle down the formation. So you want to fly smooth enough so that the guy at the end is not feeling the repercussions of any changes that takes place.
C-17s have ski, station-keeping equipment. The aircraft are electronically locked in formation, a daisy chain of heavy airlifters flown by computers, each carefully offset to avoid the jet wash of the aircraft ahead.
And the other aircraft, pilots usually have to hand fly the aircraft into position. In this airplane, it's all, the automation does all the work for you. If you get the aircraft in the approximate position that it needs to be, engage the automation, the aircraft will maintain position. For the 9-ship formation, we all agreed to do an automated drop, which meant the mission computer, it computed where we were going to release the load, and it basically flew the airplane to that point, did the countdown, and then exited the load from the aircraft.
In wartime, precision drops mean the difference between life and death to soldiers on the ground. Judges measured the distance from the pellet's point of impact to the target. Gene Carter's pellet lands a mere 30 feet from the bullseye. Others are in a tight cluster nearby. The C-141s arrive, aging aircraft, experienced crews. No computers to help this drop.
3, 2, 1, green light.
The C-141 crews are good, 2 on the bullseye, but some of their pellets are scattered. One drop fails, and they are 10 seconds late. The judges diplomatically declare a draw. Gene Carter is not satisfied with the C-17's performance. He believes a software program needs fine-tuning. Big aircraft, big problems. The C-17's troubled past. Next. Everyone is singing the praises of the C-17 Globemaster today. It currently holds 22 world aviation records. It was awarded the prestigious Collier Trophy as the most versatile airlifter in aviation history. Hard to believe a few years ago, this sky giant was a giant nightmare for all concerned: the Air Force, the Congress, and McDonnell Douglas. The search for the perfect airlifter began years ago. The U.S. had the C-130 Hercules, 40 years old, still going strong. But it's essentially a tactical transport, not the big ocean-crossing jet needed for the swift extension of military power. In 1969, the C-5 Galaxy joined the Air Mobility Command fleet. It's a huge aircraft, so heavy its weight has to be spread out on 28 tires. Maximum takeoff weight, 750,000 pounds. Pilots call the C-5 FRED. FRED is an acronym, part of which stands for Ridiculous Expensive Disaster. And there was the reliable old C-141 Starlifter, another 1960s designed aircraft. It can reach across the world, but then it has to look for an airfield with a long runway, and that might be far from the battlefront. Even now, McDonnell Douglas C-17 project manager Don Kozlowski seems bemused at the specs for the C-17.
With the C-141, it hauls nominally 60,000 to 80,000 pounds. What they really wanted was an airplane that would carry at least twice that. And oh, by the way, an airplane that would get into the tight spaces like the C-130, and at the same time haul the big heavy stuff like a C-5. So it was sort of combining some of the characteristics of all three airplanes into one.
And there was some urgency. The U.S. was reducing its overseas military commitments.
In prior years, we used to have carriers deployed around the world. We used to have fighter squadrons stationed in the NATO countries and elsewhere. We began to pull all that back. Now, the thing that was strategically important was the ability to go to those troubled spots, to move the combat power to those troubled spots without being there all the time. So airlift, instead of being an afterthought, was now a prerequisite to strategic worldwide presence.
Big aircraft, big money, bigger problems. The world's biggest, the Russian Antonov 225. It carries the Russian space shuttle. Its maximum takeoff weight is staggering 1.3 million pounds. The old Soviet regime built a few of them and gave up. The incredible Igor Sikorsky, inventor of the helicopter, built the first big multi-engined aircraft, a 4-engine monster called the Grand in 1913. It was the first successful sky giant. A few months later, an aircraft flying overhead dropped an engine on the Grand and wrecked it. When eccentric Howard Hughes decided to build the world's biggest aircraft, he had to build a flying boat. The Spruce Goose was too big for any runway. Started in 1942 and intended for war use, it had so many problems it didn't fly until after the war ended, and it flew just once. The B-52 bomber will soon be half a century old. It took 10 years to develop the B-52 back in the days when a fighter could be designed and built in a few months. It's the biggest jet bomber ever built, and it's instructive that in all that time, no one built a bigger one. And then there's the C-17. Journalist Jim Carroll has been following this story, and it's almost a lifetime work. He's been at it for 17 years and is writing a book about it.
I think the thought back in 1981 was this should be no big deal. We'll use off-the-shelf technology. We'll use the engines that are already in service or that will be in service at the time of the C-17 is actually built. It turned out to be a very big deal. Designing a new aircraft from the ground up was essentially what they had to do here. Presented a lot of problems, some that were anticipated, many that were not anticipated. A lot of that had to do with the computer systems on board. This is one of the most computerized aircraft that has ever flown. And all this computer software and hardware, the computers had a heck of a time communicating with each other at the beginning. They still had instances after the airplanes were in the air where the computers didn't work, which, you know, created some hairy moments for flight crews.
Gene Carter experienced one of those hairy moments.
We were flying along one day, and I was at 34,000 feet. I was trying to go into the low-level structure. And as I began my descent down, the computers went out on me, and I basically had a black cockpit. And but I just reset the circuit breakers, and but my altimeter had froze on the aircraft, and all my automation had frozen on me. But I just punched it all off, and we flew the aircraft down and reset the circuit breakers on the MISH computers, and then everything worked fine after that.
The computers weren't the only problem. When the wing was subjected to stress tests, it cracked before pressures reached the necessary safety margin.
When it finally began to go into full development, they thought that they could save a lot of money by starting to essentially build the aircraft and test fly it at the same time. This didn't work out the way they had hoped, because all the time that they're flight testing, they keep adding things, while at the same time they're trying to take the weight off the airplane, because obviously if the airplane is going to do what it's supposed to do, it has to have a certain weight, has to be able to fly a certain range, has to be able to carry a certain amount of payload. You can't do that if you keep adding more stuff onto the airplane. But this is what was going on with the C-17. You had sort of two things going on at once. And the competing interests, everything just kept driving the cost higher and higher and higher.
McDonnell Douglas almost went belly up with the C-17. An Air Force general was fired when he quietly advanced the company $500 million to keep it afloat. Cost was the C-17's biggest handicap. Early deliveries of what was supposed to be a $90 million aircraft wound up costing $300 million.
And that made people's eyes pop, not only in the Pentagon and not only in Congress, which was trying to watch these dollars, but potential customers. People were calling it a Cadillac in Congress. It was a very expensive Cadillac, and people realized that if the program was going to survive, they had to bring the cost down, they had to bring manufacturing quality up, they had to bring just an overall efficiency and management to the program.
To add to the company's problems, there were design defects.
When the flight tests finally occurred after 1991, they had to be suspended several times for various technical problems that cropped up in the airplanes. The wings leaked fuel, as somebody described it to me, like Niagara Falls when the planes first showed up at Edwards Air Force Base. Then they had a problem with cracked landing gear. They had thought that they didn't need basically what are like shock absorbers around the landing gear, and turned out they did.
McDonnell Douglas and the Air Force were at one another's throats. By the end of 1992, many in and out of Washington thought the C-17 was a dead duck.
I thought the program was going to be killed. I did. I thought that I was waiting for the announcement from the Pentagon at some point in early '93. I thought that they were going to kill the program or suspend the program, that nobody was going to put any more money into it.
The inauguration of President Bill Clinton changed everything.
The major turning point in this program was really the election of Bill Clinton, because it brought new civilian leadership into the Pentagon that had no stake in the program and was highly skeptical. It was politically crazy to let this program keep going the way it was.
The Pentagon announced the government would buy 40 aircraft, but McDonnell Douglas was put on probation, given 2 years to sort out the C-17 and itself. If it failed, the program would end.
This was a Herculean task, and people kept saying, well, they've already had this program for 12 years. What else can they do?
McDonnell Douglas, under the gun, brought in a whole new team of managers, restructured itself, solved its cash flow problem. Engineers and employees sought 1,000 different ways to cut costs and complexity. 15,000 fasteners disappeared from the landing gear. 735 parts from the wing assembly. Labor savings amounted to almost 300,000 man-hours for every aircraft. And the C-17s were finally being delivered on time.
Lucky for everybody, and it took more than luck. But the airplane itself was fundamentally not a bad airplane. Actually, it was a pretty darn good airplane. And they got a lot of the gremlins out of the aircraft. Lo and behold, the plane was doing a lot of what was promised.
There was one more hurdle. When Charleston's 437th Airlift Wing was equipped and trained, its 12 C-17s were submitted to a punishing 30-day test. If the aircraft passed the test, the Air Force would buy 80 more C-17s for a total of 120. The C-17s did everything they were supposed to do and more. During a simulated wartime surge, they were flying 16 or 17 hours a day. Overnight, the ugly duckling turned into a swan. One of the Air Force participants, Air Commander Martin McNulty.
The aircraft passed with amazing results. Had to have an on-time takeoff reliability rate of 90%, and it was up around 98 or 99%. We really blew the test away, and the aircraft performed much better than it even expected by its makers. So we were real pleased with the test. I think all the aircraft commanders and all the pilots love the plane. We all came from different backgrounds. Unusually, this aircraft pulled in people from C-141s, from C-5s, huge cross-section of pilots from the United States Air Force, and everybody I've talked to loves it as much, if not more, than their last aircraft. I myself flew the C-130 Hercules before, and I think of this jet as kind of a super Herc. I love it. I really, really do. I wouldn't want to fly any other plane now. I'm spoiled rotten by this plane. If I had to go back to another plane, I would probably cry.
Then came Bosnia, and the C-17s went to war.
The Bosnia was supposed to be a limited test of the C-17. Once they got the C-17 over there, the Army, they look at the C-17 and they see what it can really carry. And instead of having 2 or 3 C-17s, which was what they originally had planned, suddenly they had more than a dozen C-17s deployed to Bosnia, and it was hauling stuff into Bosnia that nobody had even put on a C-17. They'd never put it on any airplane, never mind a C-17. To say that people were extremely pleased with it, to say that the Army has suddenly discovered the C-17 more than it ever had, is an understatement. It's changing a lot of the planning for future deployments of troops, and you will see the C-17 no more in any kind of a test situation in future wars or deployments. It will be at the front of all planning decisions in the U.S. military.
The C-17 is undeniably a big aircraft. So big that it fools the eye. From wingtip to wingtip, it's almost 170 feet. It's 165 feet long. Those seemingly small winglets at the end of the main span are 9 feet high. The top of its tail is more than 5 stories from the ground. Overall, it's about the size of the C-141 it will replace, but it can carry twice the load. It can carry a maximum payload of 169,000 pounds, and it can make a combat landing on an austere field only suitable for a Hercules. The key to this enormous aircraft's short takeoff and landing abilities: blown flaps. Engine exhaust is directed at its giant flaps, providing low-speed lift. The C-17 weighs only 277,000 pounds empty, so it has a light footprint. It makes do with 14 tires, not the C-5's 28. To carry a maximum payload, airlifters like the C-17 take off without a full load of fuel. And with its blown flaps, the C-17 takes off like a rocket.
Okay, going slow down, C-25.
10 miles west of Lawrenceville VOR.
Fuel tanks are topped up at altitude. Airlifter pilots say this is where they earn their pay, holding the C-17 steady in the jet turbulence of the tanker.
406 with you, 370.
406, Jackson, Roger.
Yeah.
Taking aboard a full load of fuel can take 45 minutes. The throttles can't be left untended for a single moment. With aerial refueling, a C-17 can fly from South Carolina to South Korea without a stop.
Autopilot is disconnected, and you're cleared into contact.
The cockpit is like that of a fighter, with heads-up display and fly-by-wire.
We have a heads-up display, or what's called a HUD. It provides all kind of information to the pilot, such as airspeed, altitude, heading, navigation information. And the good thing about the HUD is it keeps the pilot's head up from down below. It keeps them looking out at all time. There used to be a rule of thumb of flying. You want to be 80% outside and 20% inside. With the C-17, you're 100% outside at all time. The cockpit was specifically designed by pilots, so it's very ergonomically designed for the pilot. All the radios are at eye level, so that the pilot's looking out at all times. The autopilot is right in the center, where both pilots can operate it as opposed to being on a back pedestal somewhere. The flight control system is a unique system in itself. It's a quad-redundant, fly-by-wire, computerized flight control system. It's different from the old yoke system in that was pulleys and cables, and this is all fly-by-wire. The stick senses pressure, and as you put pressure on the stick, it goes to a computer, and the computer will turn the aircraft for you or raise or lower the nose or fly the aircraft in any direction. And it senses the pressure, and the pressure that it senses determines how fast it needs to roll the aircraft.
A great deal of a pilot's time is spent in the rocking and rolling C-17 simulator. On its hydraulic legs, it imitates every move of the aircraft itself. With the cost of the C-17, it's cheaper and safer to simulate emergencies in the virtual reality cockpit of the simulator.
Fire number 1 engine. Fire number 1 engine.
A crew of only 3 flies the C-17. Pilot and co-pilot handle the flying. The Globemaster runs the cargo hold. So the flight simulator is coupled to a simulator for the cargo handling equipment.
Loads clear.
Everything in the immense cargo hold is designed for the swift loading, stowing, and unloading of cargo. Staff Sergeant Scott Bailey.
The C-17 was designed by a Globemaster from the bulkhead back. Okay, right over here we have a rail for loading pallets and equipment. By putting a bar in this hole and pulling up with slight pressure, we have the rail in place where we put our pallets and equipment up against. And right over here, we have a roller conveyor designed for an easy flip maneuver to put the pallets rolling across.
500-pound ramp extensions can be raised or lowered with one hand, but the ramp proper can carry 20 tons of cargo.
Another unique aspect of this plane are the tie-down devices, and back here we have tie-down chains. Now this helps my job out because when I load vehicles and equipment or whatever we have, everything is right at an arm's length touch.
The turbofan engines are built by Pratt & Whitney. Each produces more than 40,000 pounds of thrust. Mechanics can walk right in for a close inspection. The diameter of the fan blades, 85 inches.
The first stage of the engine produces where the fans that produces about 80% of our thrust. The exhaust out the back produces 15% of our thrust, and when the gas is in the chamber, in the combustion chamber, produces 5% of the thrust. The engines that you can see are highly mounted. They're really high, so going into austere locations, it prevents us from sucking up dirt and rock and FOD into the engines, which is one advantage of us going to austere locations. The C-17 has a capability to do what we call a tactical descent, which is where we bring the throttles back to idle, deploy the speed brakes, and then take all 4 engines into reverse thrust. And when this happens, the aircraft, the nose of the aircraft really drops down to around 30 to 35 degrees nose low, and you can get a descent rate of around 12,000 to 15,000 feet per minute. I've personally seen 15,000 feet per minute, and you are just dropping like a rock. It's the airplane's trying to fly forward, but you've got the engines in reverse, and there's nowhere to go but straight down.
That reverse thrust also enables the C-17 to back up a 2-degree slope with a load on, and it enables it to make a 180-degree star turn in 80 feet, indispensable on fields with small ramps.
Press rig.
And this is an aircraft that can take care of itself far from home base.
On the C-17, to change a main landing gear tire, we use the aircraft itself to jack the airplane to gain access to the tire. We'll lock the strut on the axle that we want to change the tire on, and in a sense, with hydraulic fluid on the aircraft, inflate the other main landing gear strut, which will raise that strut off the ground and gain access to that tire. We'll then change the tire off, reinstall the other tire, and lower it back down using these integral jacking struts, which stabilize as well as lift the airplane off the ground.
Captain Tom Jackson is aircraft maintenance officer.
Compared to some of the other airlifters I've been on, this is a far superior airframe to maintain. It's much more reliable. It's easier to troubleshoot for the technicians. It's basically it's a system that has taken the best of other systems and combined it into one that's kind of the best of both worlds.
The C-17 runs its own maintenance checks through its computers.
The C-17 is a network of computer systems which all tie in together on the 1553 data bus, which is like a person's spine, where all the nerves go into the spine to head to the brain. Well, that's what it does on the C-17 with all the computers. They tie into one main system, and we can interrogate that with a basic computer that we have here. Just like on your car door, when you open your car door and there's a switch that'll come open and it'll cause your light to come on inside your car. Instead of switches in the C-17, we've got proximity sensors, magnetic sensors that will tell you the position of certain things, whether it be landing gear, slats, flaps. There's 221 of them on the aircraft. They all interface into the proximity interface unit, which will tell the maintenance troop how the system is working, whether or not the proximity sensors are good, whether they're bad, and whether they're rigged properly, magnetically between the sensor and the target here.
Pilots always give a nickname to aircraft they like. Some are acronyms like BUF for the B-52. BUF stands for something like Big, Ugly, Flying Freaks. The C-17 is called the Moose.
That's a good story. When you refuel the airplane from the ground, it makes, as the gas goes in the tanks, the air comes out of the tanks and goes out a little vent, and it makes this moaning sound, more and we call it a moose mating call. It's what it sounded like to everybody. It sounds like a moose. So hence the nickname Moose hit and it stuck.
Next, the Moose on a mission. Air Force Base, part of the huge military complex at Fort Bragg, North Carolina. Bragg is home to the Airborne and Special Forces. Every 3 months, a new Red Alert team is assigned, on call for military emergencies. Each new team must undergo a readiness exercise.
The exercise that we're doing is a joint readiness exercise. It measures the readiness of the military forces. In this instance, we're doing the Army and the Air Force. The training that we're doing, to equate it to a real-life example, would be the Gulf War. I flew in the Gulf War. The Air Force went in and annihilated the enemy, where the Army was able to go in and capture them. But at the same time, you can't win a war from the air. The enemy cannot surrender to an airplane, so you have to have the Army to go in. So you can see how we work together to accomplish one objective, to win the war.
The exercise area is restricted. Miles of sand has been dumped to replicate the deserts of the Middle East, of the Gulf in particular.
And this exercise is almost similar in that they're at a moment's notice, they're practicing their readiness. How quick can they get ready? How quick can their troopers get ready? How quick can you put together a load to go on an airplane? And for us specifically, it would be to drop these loads for them, and then they'll go out and airdrop behind them.
There are no railway ties on pallets on this exercise. Gene Carter's C-17 and others load up with the trucks, Humvees, artillery, and jeeps they would carry into a war zone. The exercise calls for paratroopers to seize an airfield. A combat control team is on the ground first. Team members penetrate the target area on motorcycles, on foot, or by parachute. The combat control team's job: to scout enemy concentrations in the drop zone, and to provide wind and weather conditions for the inbound fleet of airlifters.
Combat control team really plays a major part in us getting the drop off. They're very important in that they'll go in and secure the drop zone for us. And also more importantly is they determine the weather conditions of the drop zone to make sure that we can do the drop.
I got another wind update. The wind just shifted.
11.
Okay, it's now 020 at 11.
And just the emergency procedures.
Computers, GPS, radar, every system aboard the C-17 comes into play for the drop.
Accuracy is very important. It comes down, bottom line, the only way to win a war is to put everything where everybody needs it, and everybody works together, and they can defeat the enemy that way. Surprise is the key element of winning any war. And so if the enemy doesn't know you're there, they're not expecting you, and you can get the element of surprise on them. So we go blacked out. We try to go blacked out as much as possible.
Surprise means a night attack. In the air and on the ground, the U.S. forces don night vision goggles. The goggles absorb light through a binocular, magnify it, and turn night into green-hued day.
When you look through the night vision goggles, the trees and the roads that you can't see with the naked eye, they're right before you. And a lot of our turn points may be a road X, a road crossing, a road bridge. It's a real comfortable feeling knowing where you're at. So the night vision goggles really enhance low-level flying at night. As we're flying along, we'll get the winds from the drop zone control. They'll tell us what the surface winds are. We'll plug those into the computer. We know what our altitude winds are, and we'll plug that in the computer, and it'll give us a mean effective wind, which is the wind between the surface and our drop altitude. We plug that into the computer, and it determines where we need to release the load to try to get the load to land exactly where it needs to land.
Stand by, drogue. Drogue deployed.
Low clear.
Vehicles and equipment are dropped first. They will be on the ground when the paratroopers land, ready for instant use. The C-17 systems work to perfection for this drop. The computers land one truck within inches of its target.
We were 1 yard off of where we needed to be, left or right, and we dropped exactly where we needed to drop. My crew was real happy about that. To drop personnel, the maximum that the wind can be is 13 knots. If the wind is greater, it's 14 knots or greater, you can't drop them because the guys may get hurt on the ground. For heavy equipment, it's 17 knots. So you want to make sure that the winds are within limits to do the drop.
Airborne troops move swiftly to occupy the enemy airfield. By daylight, they are in control of the perimeter. Gene Carter heads home, proud of his performance and that of the C-17. From Carter, a word for those who still question the worth of the new airlifter.
In my mind, the missions justify the cost far greater than people would really expect. I know there may be some people that say, hey, no way, it's just a waste of money. But until you've walked the walk, flown the plane, then then you can talk, is the way I say. But I'm telling you, it's the best expenditure of dollars that I think the government has spent on any type of aircraft. And I think it's time for a new airlifter, and this is the airlifter to carry us into the future and to get the job done.